Right, so an equation, instead of just simplifying, which is all we've done so far, you're looking to actually find an answer. So an equation has to have an equal sign in it, in the beginning, at the start of the question. For example, x plus 2 equals 5. So there's an equal sign when we start. That's an equation. So you do these actually in grade like 3, but they don't put an x, they put a box. Sort of like that. And they say fill in the blank. And so you'd say, okay, what number can I add to and get 5 as the answer, right? And this is the same thing. But of course, we learn methods to solve more complicated ones that we can't do in our head after grade 2, 3, 4. Grade 6, they actually start algebra, which is a confusing point in time because an X was a time sign and now it's a box. But that's all it is. There used to be a blank in your paper and now they put, or a box in your paper to fill in, and you could do it in your head with a little bit of thinking, and now all of a sudden you can't. So, an equation that we're solving in this particular section are linear equations. So what does that mean? So a linear equation, let me write this down. Do you recognize that? So that is an equation because it's an equal sign, and it is linear because if you were to graph the line, it's a straight line. Straight line does not mean a horizontal line, it just means a line you could draw with a ruler. That would be a straight line. And this is a linear equation. But if I wrote y equals 2x plus 3, for example, this is not what we're talking about. We can't solve for x here. Why not? Because there's a y. We could make a table of values, you might remember doing that, and then plot the points, something like that. This is called a linear function. A function has an x and a y in it. Okay, so that is not really a linear equation that we're solving for the missing variable. That's a function. Okay, so linear, the highest power of x is 1. That's what a linear equation is. Quadratic, the highest power of x is 2. A cubic, the highest power of x is 3. So linear is the ones we're starting with. Later, after we do factoring, we'll go back and solve more complicated expressions with quadratics in it. But for now, just linear, okay? So, let's do an example. So this is going to say solve for x. All right, so when you first start solving for x, we do what is called a balance, and in any curriculum guide that a teacher would have, they teach you to move things to the other side of the equal sign by doing the same thing to both sides, right? Later on you learn that, really you don't have to write that on both sides. So, for example, they would say, well, if we want to move the 3, what would we do to both sides? Subtract 3. So then 3 minus 3 is 0, and that's 4. So that's how you're taught first, but we learn later that we really don't need to write that minus 3 in both places. What could you just do? Yeah, I say move it to the other side. So that's it's doing the same thing. If you're saying, okay, let's move the 3 to the other side, it's a positive on this side. If we write it on the other side of the equal sign, then it's a negative. And that balances it out. If we're adding 3 to one side, subtracting 3 from the other side is the same thing. And that is exactly what you get here. Okay, so, and then what do we do at this point? Divide both sides by 2. So when I say this side, we have isolated the x term. Okay, so what does that mean? That on one side is whatever term had the x in it, and there's nothing else on that side. Okay, this will become in handy later when we've got some complicated things with radicals and fractions and stuff in it. You're trying to isolate whatever variable you want, so you want it by itself on one side. And the word to tell you to do that is isolate. So when we do trig later, I say isolate the sign x. So that means get the sign x on one side by itself, everything else on the other side. Okay, so that's the term for that. And then the 2's here, 2 over 2 cancels, and we get 4 over 2, which is 2. Okay, so that's just easy. Let's go right away to more complicated. I'm not going to subtract 3 from both sides. I am going to just move this 3 over. So in class, I often show it like that. I want to move that 3 to the other side. So I will have minus x only on this side. The 3 I'm moving equals 7 minus 3. So minus x equals 4. Now what? Divide by negative 1, or multiply by negative 1, because that will also make the x positive, or there's a third option. Move the x to the other side and the 4 to... So there's actually 3 options, and I want you to sort of think about this. This is minus 1 times x equals 4. So we could divide both sides by minus 1. Does that make sense? Remember, that minus is not attached to the x. It's just a minus 1 in front. These would cancel, and we get x is minus 4. So that's one option. I'm going to write a big or. What did I say is the other option? You can multiply both sides by minus 1. Does that not get you the same place? Minus 1 times minus 1 is positive 1, right? And then or, what's the third option? So the third option is just to move the x to the side that will make it positive. And that would mean we want to move the 4 over here, so that would be minus 4 equals positive x, or x is minus 4. So all of those techniques we use sort of interchangeably. Sometimes you might think about it as multiplying everything by minus 1. Sometimes you might think about it as dividing, and other times switching sides, especially with inequalities, is a better approach. Okay, so the switching sides thing, although it seems awkward here to have the x on the other side, with inequalities, do you know what I mean? Greater than sign or less than sign, that's the way you have to solve a lot of them, is by moving the x to the other side. So it's a good technique to learn now. All right, so that's the second one. Now, 3. Okay, so we could have something like this, a little bit more complicated, a few steps before we move things around, and that is they have these little distributive properties. That is the 2 onto, remember we say onto when we see that, onto x plus 3, minus 4 onto x minus 1. So just like when we were simplifying fractions, we multiply that all out. So 2 times x, 2 times 3 is positive 6, minus 4 times x, and minus 4 times minus 1. And then we do the same thing we just did, but now we can collect like terms, just like we did when we were simplifying. X's add with x's, so we've got a 2x minus 4x on the left-hand side. We've got a 6 on the right-hand side, and we want to move the 4 over and the 6 over. So that's a positive 4, it will become a minus 4. This is a positive 6, it will become a minus 6. 2x minus 4x, minus 2x. 6 minus 6, 0, and a minus 4 is left. You could do it in order that you see them, but it's always, if you can see something that cancels, there's a positive 6 here and a negative 6, so that's just 0, and all that's left is negative 4. The equal signs do go down the whole way, but it's in the middle of the equation now instead of the start. Don't put equal signs at the start. Okay? They have to go now in the middle. And you can line them up better than I line them up here if you want to, but you don't have to. But in typing, when you type in math, there's actually a setting that you can have your equal signs line up. So then they have the equal signs going down, or you can just have it this way. But each line does have an equal sign, but not at the start. And then divide both sides by -2, so x is 2. Okay, so here's one to try to trick you a little bit. Hopefully it won't. So do you see there's a bracket in it? So we want to get rid of that bracket first, and that is by multiplying what into the bracket? -5. What about this 1? It just stays there. It's a +1. It's on that side. So -5 times x and -5 times -2. And this is our goal always, is to get an expression with some numbers and some x's that we can put on different sides so that we can solve. So all the x's, this one's going to stay. We're going to bring that 3 over. So -5x minus 3x, because that x was positive on this side. Now be careful, because that was a -5x on the first side. And then what are the numbers? 10x is going to, or the 10 is going to go that way, and the 1. So on this side, right now, there's a 2. That's going to stay. We'll move the 10 over, -10, and move the 1 over, -1. 2 minus 10 is -8, -1 is -9. Divide both sides by -8. We get x is 9 over 8. Positive. 2 minuses make a positive. So I said that was to trick you. What do you think people do wrong in that one? The 5, they just, yeah, the 1 is a little tricky looking out there. They forget to move that to the other side, or they drop it all together when they do this. That's another thing that happens. The other is that when you carry down a -x on the first side, sometimes they don't put the negative sign in front of it. Okay, so there's lots of things that you could do wrong in that question. But if you go carefully and slow, you shouldn't make those mistakes. What about this one? So we need to expand this. So 2x plus 6 is equal to 2x minus 5. Okay, so now using some logic, not thinking about the steps in math, but just looking at this equation, 2x plus 6 equals 2x minus 5. Is that possible? No, it's not. The two x's match, so the numbers would have to match. For two sides to be equal, they have to be equal. So if you didn't notice that, so there's no solution to this one, that would be the answer. But if you kept solving it, what actually happens here? So we're going to keep this 2x, move that one over, keep this -5, and move this one over. 2x minus 2x, 0. Okay, so that, there's no x's left. Right, the x's have disappeared, and that means there's no solution. So, no x's means no solution. So, it's very likely in the real world that sometimes the problem doesn't have a solution, and you would just say there's no solution. Yep, that's, yep. So can you write undefined? No, you're solving an equation, so you're looking for a solution to the equation, so the answer would actually be no solution. When did we write undefined? Is when something didn't work. So what dividing by 0 is undefined. That doesn't mean it has no solution, because we weren't trying to find the solution. We were trying to simplify, and we ended up with a fraction that is undefined. We don't have an answer to 2 divided by 0. So on your calculator, I don't know if you've ever typed something in that says error. Has that ever happened? So I wonder if I have a calculator here. Yes, I do. So if I type in something divided by 0, it says error. Okay, so 8 divided by 0. It says error 2. Did you ever notice that 2 there? That means undefined. There's actually an error 1 on a calculator, and that means you put something in that was not mathematically correct. Like you forgot a bracket, or you put that you were going to type an exponent in, like 8 to the power, where's our random power here? Oops, I still have error. So, okay, so say I started a bracket. This one, of course, is not going to do that. But error 1 means a syntax error. You've typed in something that it doesn't recognize. Okay? So maybe you put lawn and put something after it, or didn't remember to put something after it. Okay? So error 2 is undefined. Error 1 on a calculator is no solution. It's something you did wrong. All right? So. Okay. 6. So this is similar to the last one. So when I expand that bracket, I get a similar equation, except this time it does work. 5x plus 10 does equal 5x plus 10. So what do you think the solution is here? Any number will actually work. There isn't just one number that works. So like here, 9 over 8 is the only number that if I put it here, where the x is, and here where the x is, 9 over 8 is the only thing that will make both sides equal. 2 is the only thing that will make this side equal to 6. Here, we can actually plug in anything. If I put in x is 2, I would have 5 times 2 plus 10 is equal to 5 times 2 plus 10. So 10 plus 10 is equal to 10 plus 10. Do you see that no matter what I put in there, both sides will still be equal? If I let x equals 3, if I let x equals anything, both sides are still going to be equal. They're going to work, and it's going to be equal. So what happens when I actually go to solve this? So you didn't notice that both sides were equal, and you go to solve it. So the 5x stays on this side, that one moves over. The 10 stays on this side, and this 10 moves over. Is 0 equal to 0? Yes, that's true. So this does have no x's, but we have, right, a true statement. So in math, when any value works, it's said to have infinitely many solutions, and you would say that the solution is what? Not infinity. Do you recognize that? So this little is read as element of. X, or x is an element of our, what's our real numbers. Means we can put in any decimal or fraction or number, anything at all onto both sides, and it will work. So here we would say the solution. So the last solution was actually no solution, was the solution. This time, the solution is x is an element of real numbers. So that would just say that anything will work.